All right, congratulations. You made it to day 3 or part 3 of section 1-6, which is talking about the different transformations that are taking place. Today we're going to focus in on the dilations, which are going to be our horizontal and vertical stretches and shrinks. And we're going to then combine all of our transformations, so our translation, our reflections, and our dilations together to see what's happening to our graphs. So you have seen this slide now 3 times as far as what a transformation is and what the 3 different transformations are. So like I said, today we're going to focus in on a dilation and figuring out how we can change the size of a graph by vertical and horizontal stretches and shrinks. So the best way that I can illustrate this is thinking of a digital photograph, and what better than a picture of my dog. And this is Lucy, and since Halloween is right around the corner, this was her dressed up last year as Audrey Hepburn from Breakfast at Tiffany's. And when you think of a photo and you wanted to enlarge it or make it smaller, what we do is we usually grab from the corner, because then it keeps it the same. Okay, we are making a similar size, whether you make it smaller or bigger. It's not distorting it at all. Now, if I go ahead and I change this and I bring this up, there we go, and I think what I'm doing here is I'm bringing this up here. I am making a vertical shrink right now as I do this, and what's happening here is you'll see that it's getting wider. If I do a vertical stretch, it's making it longer. If I do a horizontal stretch, it's making it wider. If I do a horizontal shrink, it's making it skinnier. Okay, so this is a few things that we have and what we're going to be looking at with our functions. Here I just have a quadratic, and by moving this quadratic and changing its shape, we can change the vertex. We can figure out what new x and y intercepts, what our zeros are going to be. So by changing the shape, we can now alter our problem of how high something is going to get for maximum height. You know, for example, how long is it going to take for something to hit the ground? Examples like that. So let's go ahead and look at what's happening. Here are some different situations you're going to come in contact with. And like all of the other transformations, we're going to be dealing with inside and outside change. Outside change is going to be happening outside of your value of x, where the inside change you're going to see is happening with some parentheses. If you can hear my dog slurping up water in the background as we talk, maybe. Sorry, it's kind of loud. But we have the 1/2, which is going to be inside change. And the outside change is what is going to be telling us if we have a vertical stretch or shrink. And in this case, with the 1/2, I'll be showing you how that's a vertical shrink. And if we have inside change here, we're going to be talking about a horizontal stretch or shrink. Okay, hold on, I gotta stop my dog here. All right, so going on now, we'll look at these horizontal and vertical stretches and shrinks. So starting out with horizontal stretches and shrinks. This is when we're working with that inside change that we were talking about. And when we look at that inside change, we have a function here, 2 different ways of looking at this. You have f of x divided by c, and you have 1/c times x. So these 2 expressions are the exact same thing, and that value of c is what's going to tell us if we have a horizontal stretch or a horizontal shrink. So if the value of c is greater than 1, you will have a horizontal stretch. Okay, and I'll go into some examples here in a second. If you have a value of c which is less than 1, but it is going to be greater than 0, okay, you are going to have a horizontal shrink taking place. So to kind of look at these 2, let's look at some examples to help us out. All right, so here I have 3 examples of a inside change, which is going to be our horizontal stretch or shrinks. So when I look at the first one, I have y equals f of x divided by 2. Now, this is the exact same thing as if I wrote this out as f of 1/2 x. And what this is doing here, now if I want to figure out what c is, I need to look at the denominator here. So it's x divided by 2. So this is telling me that c is equal to positive 2. This means that we have a horizontal stretch and by a factor of 2. If I look at the next one, so I have f of 2x. This is where it gets to be a little bit difficult because when you think about this right now, you're not taking x divided by anything. So right now you have a 1 right down there. Well, now you have to think about what the value of c is. So if I rewrite this, or actually I can't really rewrite it, but if I have 1 over c and that equals 2. Well, think about this. If 1 over c equals 2 and I solve for c, we'd multiply both sides of the equation by c, and that would give me 1 equals 2c. And then I would now have to divide by 2, and I would get c is equal to 1/2. So this one's really more difficult to see, but we get a value of c here to be equal to 1/2. And this tells us that we're going to have a horizontal shrink by a factor, oops, by a factor of 1/2. So it kind of goes with the whole idea of when we've been working with all that inside change, it's the opposite of what you think is going to happen. So here, when you see the first one, x divided by 2, rather than it being, divided by 2, now you've got this 1/2, so you think it's going to be a shrink. Well, we're doing the opposite of that, which gives us the stretch. Here we have 2 times x, so just when you think that you're stretching it, you're actually doing the opposite, which is going to be a shrink. With the last one here, so 1/3 x, this one's easy to see that your value of c is 3. And so we're going to have a horizontal stretch by a factor of 3. So when you have inside change, that is going to be your horizontal stretch or shrink. Now let's look at what happens when you have vertical stretches and shrinks. So this is the outside change, and this makes it a little bit easier because you don't have to worry about being the opposite and being that reciprocal portion. But we're going to still follow the rules that we're going to have a stretch if your value of c is greater than 1, and we're going to have a vertical shrink if you have a factor of c which is less than 1. And we're going to want that value to be greater than 0, so it's going to be some sort of fraction within there. So a few examples to look at here. Outside of y equals 2 times f of x. So this outside change right here, this is telling me that c is equal to positive 2. So we're going to have a vertical stretch by a factor of 2. In the next one, we have y equals 1/2 times f of x. So this is telling me that c is equal to 1/2. And so we're going to have a vertical shrink by a factor of 1/2. And then the last one here, we have f of x divided by 3. So this right here is the same thing as taking 1/3 times f of x. And our value of c here is going to be 1/3. And so we are going to have a vertical shrink by a factor of 1/3. So hopefully as we've been going through some of this, you've noticed that all the inside changes are really the opposite of what's happening. So when we were doing our translations and we were moving something to the right, instead of seeing x plus 3, we saw x minus 3. It was the opposite. Same thing here with the scale change, and when you have the inside, it's the opposite. So when you see 3 times, you're actually doing the opposite of that, which is going to be your reciprocal. So let's look at a couple examples just to kind of help bring this home, or this whole idea home. So if we have a parent function of the natural log of x and we want to do a horizontal stretch of a factor of 3. Horizontal stretch, so that's going to be inside change, and it's going to be replacing x with x divided by c. And so now we have the function f of x is equal to the natural log of x divided by 3. Or you could write this out as the natural log of 1/3 x, and that would be a horizontal stretch of 3. A vertical shrink of 2/3, we're going to go outside change for this one. So here I'm looking at g of x and of x squared. So we're going to keep everything the same. We're going to take 2/3 times x squared, and that's all we need to do. With the last one here, we're going to do a horizontal shrink of 3/4. So when we do a horizontal shrink, since it's horizontal here, we're going to go inside change. And I'm going to go ahead and take e to the power of x. Now it's x divided by 3/4, because it's x divided by c, and c is equal to 3/4 in this problem. Now, one second. All right, so when you're taking x divided by 3/4, we don't like to have fractions in a fraction. So what you're doing here is by dividing by 3/4, you're actually multiplying by the reciprocal. So you're taking x times 4/3, which is going to give you 4x over 3, or you could have it as 4/3 x. And so here our function is going to be e to the power of 4/3 x, and there's our horizontal shrink of 3/4. So what we've now done here is we've gone over a couple examples with the shrink and the stretch. If you wanted to reverse this whole process, thinking back to what we've been doing, if I have function t of x, hopefully you can see right here that our parent function that we're working with is the square root function. And this 5 that's right here, it's an outside change. So we are working with a vertical stretch. And we're going to do a vertical stretch of by 5, by a factor of 5. With p of x, when I look at this one here, your parent function you're working with is the absolute value function. So you got the absolute value of x. But there is a translation that's in there as well. So we're working with the absolute value of x plus 3. And what's happening here is now you have inside change with that 2. And that 2, you got to think of it as, you know, this 2 equals 1 over c. And so now when we solve, again, multiplying both sides by c, and you get 2c equals 1, this is going to tell us c is equal to 1/2. And so here we have a horizontal shrink by a factor of 1/2. So now if we go back to, I know I'm kind of almost to 15 minutes here, but let's take a look at an example and put pretty much everything together of what's taken place and inside change, outside change, and all of that. You'll see that we have the function of k. And with that function of k, all of this that's going on here is dealing with inside change. That +4 is the only thing that's really working with outside change. So things that we have going on here, that +4 right here, this is telling us that we are going to be taking our function and moving it up 4 units. The inside change of adding 7 right here, this is what is going to be moving our graph to the left 7 units. So that's our translation. Then you have a couple other things that are taking place. You have this negative that's inside, which is telling us that we are going to be reflected over the y-axis. And then you have this 2 that's in here as well. And since that's inside change, what we have going on here is we have a shrink, a horizontal shrink. And our horizontal shrink is by a factor of 1/2. We have all of this that's taken place for our one function. So what I want you to try and do and bring into class tomorrow, again, I know this is a lot being kind of put at you and we'll take our time if we need to, but I'd like you to try and take a function here of the natural log of x, so ln x, and what I'd like you to try and do here is, can you come up with a function for the multiple transformations? So can you come up with a function that shifts this graph to the left 2 inches, makes a vertical stretch by a factor of 3, has a vertical translation of 5 units up, and then let's see if you can figure out what to do if we reflect it over the x-axis. So let's see if you can try and come up with a function of f of x with all these transformations taking place. As you've gone through these videos of these 3 days, you need to be sure to let me know if there's anything that is difficult or that you're not quite sure of, so that we can stop back and go over anything. If I don't hear from you guys, then I assume that we are ready to move on. So make sure you let me know of any questions. Otherwise, we'll see you in class.